Hey class, good morning. So again, this is a presentation in thermodynamics. So maybe this is the last presentation in the processes of ideal gases. So this is polytropic process. So previously, we already finished isentropic process. So actually, the equation of the isentropic process and the polytropic process are almost similar. So we will only replace the constant k with a value of n. Okay? With n. Okay. So let us now proceed to the discussion. Okay? So here is the polytropic process diagram. Okay? So the equation here. So actually, the TS diagram for isentropic is that this line is straight, okay? Since S is constant, okay? So, but for the PV diagram, there is no such change, of course, okay? So, the equation for isentropic is PV raised to K is equals to constant. So, by this time, we are now replaced it with PV raised to N is equals to constant, where 1 less than N less than K, okay? So, this is the diagram. So again, the PVT relationships, of course, here i- uh, is the same, of course, in isentropic. So that is PV equals to MRT. Okay. So also T sub 2 or the ratio of T sub 2 and T sub 1 is equals to P sub 2 over P sub 1 n minus 1 over n. Or in terms of volume, the relation of the temperature is P sub 1 over B sub 2 raised to n minus 1. Okay. So we only change k with n. Okay. So again, here is the derivation of the formula in the previous slides. Okay. So the combined ideal gas equation P1V1 over T1 is equals P2V2 over T sub 2. And then from the equation PV raised to n is equals to k. So and then putting inside or outside or getting the ratio of the pressures till now become P sub 2 over P sub 1 equals to P sub 2 over P sub 1 and then T sub 1 over T sub 2 raised to n. Okay? So this is the same as with the formula in the previous slides. Okay? So for non-flow work, so that is again work non-flow is equals to the integral of P differential volume or that is area below the PV diagram. Okay? So again, PV raised to n equals to constant and then P equals C over B raised to n or simply P equals to C multiplied by B raised to negative n. Okay? So and then substituting now the constant of course from the formula for the one non-flow process. So work done flow now is equals to C b raised to negative n plus 1 over n plus 1 limit of course from b sub 1 to b sub 2. Okay? So the work non-flow now, substituting values and then integrating. So work non-flow is equals to MR or the P2 B2 minus P1 B1 over 1 minus N, but PB equals to MR and then replacing it, MR now equals T sub 2 minus T sub 1 over 1 minus N. So this is almost the same class in the previous topic. We only change N or K with N. Okay? So for heat transferred again, so but actually for heat transferred and isentropic that is zero. So by this time there is not there is no longer zero value for Q. Okay? So actually for Q, the equation again is Q equals to T multiplied by ds or the integral. Okay? So limit from 1 to 2. Or for the First corollary of the first law, so that is for closed system, Q rather, is equals to delta U plus work non-flow. Okay, so substituting values, Q equals to MCB delta T, and work non-flow is MR delta T over 1 minus N, and then manipulating the equation, so the value now is equals to Q, or Q rather, is equals to MCN delta T. But Cn can also be computed. Okay? So, using now this formula, Cb multiplied by K minus N over 1 minus N. Okay? So, another is the change in internal energy. Again, this is always equals to mCb delta T, same as for the change in enthalpy. That is mCp delta T. Okay, so for the change in entropy, again, the equation is delta S, the integral of dq over T, limit from 1 to 2. Substituting values. Okay, so your problem here only is determining Cn. Okay, so delta is now equals to Mcn ln of T sub 2 minus over T sub 1. Take note, class, that T sub 2 and T sub 1 should be in absolute. Okay. Next is the steady flow work. Again, steady flow work is the area behind the PV diagram, or that is equals to work steady flow is equals to negative integral of B differential pressure limit from 1 to 2. Again, the equation PV raised to n equals to C. Substituting, work steady flow equals to the negative integral of Cn, C raised to 1 over N, P raised to 1 over N, dP. Okay? So, substituting now the values. So, that would now become work steady flow equals T raised to negative N. So, we put this outside the integral sign, and then integrating P raised to negative N plus 1, negative 1 over N plus 1, limit from pressure 1 to pressure 2. Okay, so substituting or applying the limits now. So, that would become work steady flow equals to N, P sub 2 B sub 1, 1 minus, or minus P sub 1 B sub 1 over 1 minus N, or simply work steady flow equals to N multiplied by work non-flow. Okay, so as easy as that, class. Okay, thank you very much. So of course, maybe the example here will be presented during the second presentation. Thank you very much, class. So that's all.